All right, we're going to look at uh, some different expressions here, and we're going to see if we can use truth tables or maybe a little common sense, a little of both, to simplify these expressions. Because if you see some of these expressions, you really shouldn't keep them complicated if there's a way to simplify it. It's kind of like leaving something unsimplified in algebra. It's kind of gross. You don't want to mess with it in the unsimplified form. You want to mess with it in a simplified form. So let's start with our Q. Our Q can either take the truth value of true or false, which means not Q is going to be the opposite there. So let's look at not Q. So not Q is going to negate whatever value we got here, whatever value we got for not Q. So it's going to negate false, it's going to give us true, it's going to negate true and give us false. Now you'll notice that is the exact same values that we got for Q. We call this being logically equivalent. Meaning you can substitute one statement for another and they're going to give you all the same values. So if they're logically equivalent, you should be able to substitute one for the other. So not Q is identical to Q. So really, that's just the same as Q. All right, Q and true. Well, here that would be true and true. Okay, well, true and true returns true. False and true returns false. Okay, you'll notice this statement is logically equivalent to Q. Well, let's think about that. Well, that's because we need both of these to be true, and this one's already true, so everything's dependent on this guy. So Q and true is just the same as Q. Q or false. So this could be true or false, which is going to give us true. This could be false or false, which gives us false. And again, this is logically equivalent to Q. So everything is riding on whether this Q is true or not, because this guy's false. It's completely dependent on whether that Q is true, whether or not this statement will be true or not. Okay, what about Q and false? Well, true and false is going to be false. False and false is equivalent to false. Well, this guy, no matter what, is false. So this is actually logically equivalent to just false. That statement is always going to be false. So you might as well just say, okay, this is false. I'm missing one. Let me go ahead and insert that in there. Q or true. Okay, so Q or true. So true or true is true. False or true is true. So this is always going to be true. Which makes sense. You only need one statement to be true, and you already have a true statement. So this is redundant. You might as well go ahead and say that it's true. Scooch this over just a little bit. So let's look at Q or not Q. And then after that, we'll look at Q and not Q. So true or false will give us true. false or true will give us true. Now, let's think about this a little bit. So these are always going to be opposite values. Q and not Q, those are always opposite from each other. So one's always going to be true, one's always going to be false. And or, all we need is a single true. So one of those guys has to be true. This statement is always true. Q and not Q. Well, we could have true and false, which is false. We could have false and true, which is also false. Again, I know I'm always going to have a true and a false statement. I need them both to be true, and that's never going to happen. So this guy is going to be false. So let's review. So double negation gives us Q. Q and true or Q or false, those both give us Q. These statements right here, this one we know it's always false. This one we know it's always true. This one we know it's always true. This one we know it's always false. So these are not simplifications I would memorize, okay? But these are things that you can logic out real quick. You don't need a truth table, okay? Just a quick bit of logic. You should know that all of these can be simplified if you see them. And you don't have to memorize how to simplify them. Just logic it out a little bit, and you should be able to get there.